Sarita, you can unmute and share your screen. Sarita? Uh, Okay. I think she has left the meet. Pushpak, you can unmute.
Yeah. Hello, sir.
Yeah. You're here for the presentation, right?
Right. Yes, sir.
Okay. You can share your screen and turn on your camera.
Yes.
Yes, sir. Am I audible?
Yeah, you're audible.
It's is my screen visible?
It's visible.
So, good evening, everyone. I'm Pushpak Suryawanshi from Machine Learning and Deep Learning Group, and today I'm going to deliver a presentation on a topic: future location prediction system using Data IQ Data Science Studio. So let's start. So these are the table of contents which I'm going to present today. So let us see first the task given to me and the objectives of the task. So the task given to me was to develop a future location prediction system using Data IQ Data Science Studio and deliver a professional Scrum presentation on it. So let us see what is Data IQ first. So talking about Data IQ, it is a data science studio, which is a collaborative data science software platform for data professionals. Means all it is intended for data scientists, data analysts, data engineers, data architects, CRMs, and marketing teams. And it is a very useful software in which the data scientists can can use the software without writing the code. So it is a centralized working environment that makes it easy to manipulate data, quickly explore and share analysis, make predictions very easily, and creating AI models with very few clicks. And everything is we can visualize in front of our eyes, which makes it a very great tool, and we can easily understand what is the backend, how is the code working, how is the model working, and how it's being trained, etc., etc. So these are the things we can do without coding in Data IQ. Firstly, we can do smart data ingestion. Means it Data IQ automatically recognizes the data set and what are the columns in it, what are the features in it, etc. So we do not have to specially tell Data IQ that these are the columns, these are the features, and what we have to predict, what we have to note, etc. The Data IQ automatically takes care of it. So secondly, it processes data and types very effectively, and we do not have to change the data types for a better understanding of Data IQ. It automatically takes care of it. Thirdly, data cleaning. Most of the times when we write the code for these machine learning algorithms, or when we do data cleaning, we have to write a lot of complex codes, and most of the time most of the time is being utilized in the data cleaning process only. But here, Data IQ Data Science Studio automatically takes care of it, and we do not have to write extensive code. We have to just do it with a few clicks, and boom, the data cleaning is done. So it also helps us to extract Twitter data. It also helps us to create ML model very easily. It is also helpful for us to create, combine, and join data sets uh, uh, with traditionally with using code, we combine and join data set using SQL, but here we can do it with just a few clicks. So Data IQ, which is also useful for working with geospatial data. For example, dealing with latitudes, longitudes, which we'll do in this task. It's very useful using Data IQ. So these are some of the applications of the Data IQ that it is used for customer segmentation, fraud detection, customer scoring, or calculating the scores, etc. It is also useful for many deep learning and NLP tasks. So it used to simplify the automation and industrialization of processing chains such as data collection, data cleaning, data preparation, ED, etc. For our better understanding of data, and automatically Data IQ platform takes care of it. We do not have to extensively write the code of it. So this is the main feature of Data IQ, that we can create models uh, and process the data. A task given to is very easily without extensively writing the code. So let us see what are the machine learning algorithms that we have used in this task. Firstly, let us look at the data set. So the data set contains the details about the journeys of various people from what time they started their journey till the time they reached their destination. So these also contains the location of the start location and end destination. So ID means the person ID. Event start time means the time at which the customer or user started their journey. The event time end means the time at which the user ended their journey or came to an end. So latitude start and launch start means the location of the user when at the start time of the journey, and lat end and launch end means the location of the user when at the end of the journey. So we have to predict the end location, means the lat end and launch end in this task, to predict the future location based on the other features, that is lat start, launch start, event time start, and event time end. So these are the two machine learning algorithms I have used in this task. So first is a lasso regression. So lasso regression is an advanced type of linear regression in which the goal is to prevent overfitting. And in traditional linear regression, the goal is to find the best fitting linear relationship between the independent variables and the dependent variable, which is a target variable. In this task, the target variable is the end location, that is end, lawn end, and lat end. So, however, when there are too many features, this can lead to overfitting. Overfitting means when the model is trained on a training dataset, it performs the best on training dataset, but it does not perform that well on the testing dataset. So this leads to overfitting, and which reduces the accuracy of the model. So lasso regression here is used to prevent that overfitting. While this lasso regression does this by adding a penalty term to the linear regression objective function. So linear regression penalty term is also defined as cost function. Cost function for lasso regression is I think 1/2m into the sum of residual squares, that is y minus y dash. So lasso regression we have used here to predict the lat end means the latitude, and XGBoost we have used here to predict the longitude. So XGBoost, what is XGBoost? So XGBoost is a popular machine learning algorithm used for regression and classification tasks. So XGBoost is a type of ensemble learning category. Ensemble learning means combining two or more models to make a more powerful model. It is known as ensemble learning. So XGBoost is comes under ensemble learning category, and it is known for its high predictive accuracy and efficiency. So XGBoost we have used here for calculating the predicting the longitude, and XGBoost we have taken XGBoost is a combination of many decision trees coming together, and by combining the outcomes of various decision tree, the value assigned to the new variable is taken as at its majority. So this is the working of XGBoost. So next, let us look at the data science data IQ Studio. So this is the overview of this is the whole workflow of the data science data IQ Studio. So firstly, we can see here, this is the location data set. When we click here, we can see here what are the contents of the data set. So these are the data start data set. It contains all the features as we have seen before in the slides. Secondly, so this is a symbol for training the data set. So we have trained the data set, then we have predict the destination latitude. So in destination latitude, the prediction is as follows by using the lasso regression model. So this is the then we evaluate. This is the star symbol is for evaluating the prediction. So we get the prediction data set as follows using the lasso regression. So this is the prediction we have got. This is very close to the actual values. So this means that the prediction is very good, and error is also very minimum. So it's a good sign. Next, we'll look. So what we have done is, when we get the predicted latitude data set, we have trained the same data set for longitude for predicting the longitude data set. So this is because this predicted latitudes we have done using the best algorithm, that is lasso regression. So using the same data set is very useful, and it is very useful for then taking the whole data set again and predicting the longitude score separately. So we take the predicted latitude data set and conduct the same training and testing on it. So using the XGBoost, we get the predicted data set at predicted longitude data set as follows. So here the prediction is on the extreme right column. So here is the data set we are getting. So here also error is very minimum, which is a good sign. So we can also say see here the relative error is very low. Relative error is the difference between the actual and predicted values. Coming back to the flow. So predicted latitude matrix. So we can see here what is the actual evaluation of the model we have done. So evaluated variance score is we are getting very close to 1, which is a good sign. Then mean absolute error, which we are getting very close to 0, which should be less close to 0. So it is a very good sign. So mean square error is also very low. Then MMP means mean absolute. Uh, I'm not remembering the full form, but yeah. So root mean square error is also low. Then R square error is also close to 1, so which is a good sign, which is helpful in calculating, predicting the accuracy. So when we compare the algorithm results of two machine learning algorithms that we have used here, lasso regression and for XGBoost, so we get as EVS, that is explained variance score, as 1. So mean absolute error is very low, as we have seen in the data science data IQ studio. And mean absolute error is close to 0%, and here is close to 0.01%. So mean square error is also very low, and root mean square error is also low compared to is low for XGBoost compared to the lasso regression model. And Pearson coefficient is 1, so which is a good sign. R square score is also 1, which means the model has a greater accuracy. And the R square score, the better the R square score, the more the value is close to 1. So we are getting the value as 1, which means it is almost 100% accurate. So the results and outcomes that we have seen here. So for predicting latitude, here is the workflow of the model. So we have just used the here we have used the lasso regression model, and this is the first part. And using the same dataset, that is predicted latitude dataset, we have trained the model on XGBoost, and using the XGBoost, a machine learning algorithm, and then we have got the longitudinal score. So these are the final predicted values of this is the longitude, and this is the latitude. So conclusion. So in this task, we use the data IQ data science studio to build our future location prediction system. So firstly, we predicted the latitude by using the lasso regression, which we found the best algorithm for predicting continuous values. So lasso regression we have used here because regression algorithms are very good for predicting continuous values, whereas classification algorithms are best while predicting the discrete values such as 0 and 1, true or false, etc. So in that cases, classification algorithms like logistic regression is very useful. But here we are predicting continuous values such as latitude and longitude. So regression algorithms are best. So it gives the best accuracy compared to other algorithms. Then using this predicted latitude, we predicted the longitude values using the XGBoost algorithm. So both of the algorithms gave us the best result and accurately predicted the location of the person. So these are some of the references that I've taken from. So any questions you can ask me or at my email ID. So thank you, sir. This was all about my presentation. And thank you for giving me this opportunity to deliver a presentation. Thank you, sir.
Yeah, Pushpak, the content that you have provided has been very thorough. One thing that I would like to add in your entire presentation is that in a lot of your slides, you have
Yes,
included paragraphs. See, the thing is, whenever you are giving presentations, right, try to keep all of the content that you show on the slides, reduce them to bullet points. Because the thing is, what is the audience going to do? Is the audience going to read what has been written on the slide, or is the audience going to listen to you? We can't do two things at the same time, right?
Right.
So that is something that you have to do. The aesthetics of the presentation were also very nice. There were no problems over there. Can you show me the demonstration once again?
Yes, sir. Yes, sir. So workflow.
Yeah, it's loading, right?
Yeah.
Oh, you did not try using other models that have been provided by Data EQ?
No, sir. But we can do that.
Yeah, of
For
course. That's why I'm asking, because how did you come up with the, what do you say, the result that XGBoost and lasso regression could be the potential algorithms that could have been used?
Yeah, actually, I tried one or two algorithms before using these algorithms.
Okay.
Like linear regression, I tried. Then
Mhm.
decision tree, I tried.
Mhm.
But the accuracy was coming very low, close to 70-80% accuracy was coming. So
Okay.
when I used these models, then the accuracy was coming a little bit higher.
Okay.
So I
Hmm.
finalized to keep go forward with these models only.
See, even if you're finalizing, particular algorithms, you have to show all of the other algorithms that could have been put to use. Otherwise, the
Okay.
question will obviously be raised, right?
Right, right,
There
right.
are so many other algorithms provided by they're built inside the Data IQ platform already.
Right, right.
So
Yeah.
next time in all of the future upcoming projects, try to show in comparisons
Right, right, right.
so that it gives more clarity as to why these are the
Yeah,
algorithms that can actually work when compared to
yeah.
the other algorithms. Okay. Other
Okay,
than
okay.
that, it was okay. No issues.
Okay.
Yeah. You can stop sharing your screen. And I don't think there is anybody else left for today. So you can leave the meeting.
Okay, okay. Thank you, sir.
Yeah. So with this, I will be concluding today's presentation. Thank you everybody for joining us.